Hey everybody, this is Duffy. How's it? I hope you all are doing okay today. I am getting ready to go through an exploration of kubectl-trace. Let me just close my door real quick. I'll be right back. All right. So today is also the first day we're actually we're using StreamYard to host this. It'll be really kind of an interesting experiment. Let's say hello to a few folks. Let's say hello to Khalid. Good to see you, Khalid. And hello to Noel and Mazar. Good to see you all three. So this is actually kind of a cool thing on the interface of StreamYard is that I'm able to actually see you and highlight comments. So if you ask me questions during the show, I'll be able to relate those questions inside of the show. If somebody in the comments can give me a thumbs up, if you can hear me okay and you can see me okay, all that stuff is working, making sure all that works okay. Hello, Mr. Kyle. Good to see you, Kyle. All right, one of the first things I wanted to share with you all, let's see, content, is some of the news of the week. And so one of the things I wanted to specifically cover today is the CFP for the eBPF Summit is extended through the long weekend. So you get a few more days to get those submissions in. We've got a pretty good number of submissions already. If you haven't already checked it out, definitely go to eBPF. I don't know what that's going to take me to, bpf.io. And up here at the top, there's a pre-register, and there's also a 2021 CFP or call for proposals. Definitely get them in. You have over the long weekend to get it done. So it's been extended. Please make sure if you want to get a talk in for eBPF Summit this year, happening on August 18th and 19th, it would be great to see that gets done. All right, so please join us and register for the summit and come be a part of it also. So that's better. Now you can see me and the stuff. I was just realizing that you couldn't see me at all. All right, so definitely get that in. Lots of other stuff. I've been pretty busy this week, so I haven't really gathered a lot of news this week. So, I mean, we're probably just going to jump straight into it. And I'm going to jump straight into it with kubectl-trace. One of the fun things that happened to me this week with regard to this particular episode is that I put up the tweet saying that I would be back up this week talking about kubectl-trace and exploring it. And my good friend Leo, who is one of the contributors behind this, and I think probably one of the main contributors, kubectl-trace. It's hosted under the IOVisor organization. And if we take a look at the contributors here, this very gentleman here, he sent me a tweet saying, kubectl-trace is on eCHO. Am I dreaming? What's happening? And I was like, I think it's going to be awesome. So I'm really looking forward to doing that. Let me say hello to a few other folks. Good to see you all. Looks like we're just getting thumbs up. We got a hello from Sudipto, so good to see you. And yeah, things are good. Let me turn. So the next thing I'm going to do is I'm going to go ahead and set up an environment live here. And we're going to start exploring kubectl-trace, like what it takes to get things set up and how to play with it and stuff like that. So I think right now what I'm going to do is I'm just going to focus on just getting like my standard Kubernetes environment set up locally. And right now my plan is to do that with the too many buttons happening here. So I got to like narrow this down a little bit. But my plan to do is to use Minikube for this. That way we get like one kernel per VM, and we can kind of play with it that way. Let me turn this overlay off so you can see the whole screen. I'm going to grow it up a little bit. There it goes. So I think that should be visible. So I've been leveraging a bunch of different technologies to do this. Today, I'm actually just going to use Minikube to stand this up. I'm going to create a 3-node Minikube cluster. And I think I covered this in like the first episode that I was on in eCHO, but it's a pretty new thing for me to actually realize that Minikube actually can support multiple nodes. So that's actually kind of cool. Minikube start, nodes equals 3. Equals. Let me just take a look at my settings in another environment here. In fact, we could just use this one. This is great. So let's do. So this is actually kind of an interesting scenario. The way I've got this set up is I've got an nvar-c that holds all of the configuration for my Minikube command line pieces, because Minikube honors the environment variables for stuff, right? So if I want to actually configure the CNI or set the network plugin to CNI, even give the Minikube network a name, what have you, I can actually do all of that from environment variables. And since I'm a pretty heavy user of DRENV, which is dremv.net, if you haven't checked it out, it's pretty neat. I'll just take you there real quick. I actually just talked about this on another session this week. So DRENV gives you the ability to define inside of a directory an environment file, and you can populate that environment file with whatever environment variables you care about. And then as soon as you move into that directory, or even subsequent directories down the tree from there, you can actually control what happens with those environment variables. They will be loaded automatically, or they won't be loaded automatically. So in my case, what you saw, if I move out of this directory, you can see DRENV unloading, and if I move back into it, you can see that in the environment variables that have been loaded. So you have Minikube CNI, Minikube network plugin, all of these things have been loaded up. And I haven't configured a local cube config that's been commented out, so it'll be the global cube config that gets configured. So that's actually pretty neat, and all you have to do to turn it on is download the software, obviously, and then put a hook into your bash RC that sets this up. So, or your ZSH, whatever it is, whatever shell you're using. So let's get this started up. Since I have all of this configured locally, I'm just going to do Minikube start. And we'll get this guy going. This one tells me that since I've selected network plugin CNI, I'm going to provide my own CNI. Fortunately, I know just what I want to use. So we're gonna show how to get that installed as well. I've got this configured to use containerd. That was another piece that you can configure, which I thought was pretty neat. You can set your container runtime. I think by default it's still using Docker, but you can set your container runtime to use containerd or also Podman. It's like Minikube has really come a long way in its flexibility. I'm still a huge fan of Kind, but I want to make sure I make this statement. Like in my mind, Kind and Minikube provide different overlapping functionality, but it's not the same functionality, right? So if I were developing against Kubernetes, the code base, I would probably use Kind for that, because Kind is great for using it as a build environment for Kubernetes. You could even use Kind to do testing against the Kubernetes code that you develop, right? But Minikube, I think, works pretty well in my particular case, where just because I'm actually using something that leverages a kernel technology like eBPF, and I want to make sure that there's no confusion between the different nodes, I just want to make it so that I have one Linux kernel on each one of my nodes, not a shared one across all the nodes. In Kind, you absolutely do get a shared Linux kernel across all your nodes. If I'm running on my Linux laptop here, Kind is actually going to use the kernel that I have on my laptop. If you're running on a Mac or a Windows machine, what ends up happening is you end up using the kernel that is on your associated with your Docker machine. Because when you run there, you're actually basically starting up like a little virtual machine, and you leverage that kernel for all of the containers that you start. So pretty interesting. So we got our cluster up. Let's go ahead and do our Cilium install version v110.0. And this gets Cilium brought up in here. Won't take too long here. And then we'll have our environment set up, and then we can kind of start playing with kubectl-trace, get it installed. And my plan for today is actually to kind of go through some of the examples that are there, and also just do like a little bit of exploration. One of the big questions that I had in my mind, I'm not sure how many of y'all have thought about this as well, but like, because we're leveraging eBPF at the kernel layer, I wonder what happens when you start using other technologies that also leverage BPF at the kernel layer, right? Like, do you end up in a state where, like, is there any chance of overlap or anything weird like that? And I doubt it right off. Like, I don't imagine that having multiple processes, because really at the end of the day, what's happening is that eBPF is sort of like an event-based system, and the consumers of that event, I don't think are exclusive, right? So I don't think you can figure it in such a way that like all events from this particular source, like from a particular network interface or from related to particular syscalls in a given process. I don't think you can make an exclusive lock. I don't know that for sure. I'm still kind of exploring this technology myself, but kind of interesting stuff. Oh yeah, thank you. I'm actually in the office today, so we're having a going away party for one of my coworkers, and you can kind of see, that's downtown Mountain View right there, and like the hill behind it and all that stuff. Kind of looks like I'm coming from a cloud, but pretty. All right, so we got Cilium installed, Cilium status. All that thing's working, Minicube's up, all things are good there. Let's go ahead and jump back over here, take a look at kubectl-trace, and we're just gonna work through like what this says, what it does, and how it works, and see if we can get it working ourselves. All right, so kubectl-trace is a kubectl plugin that allows you to schedule the execution of BPF trace programs in your Kubernetes cluster. We can install crew, we can install pre-built libraries. I think I have crew installed. Let's just make sure. Kubectl crew. Apparently I had it installed, but I don't anymore. There we go. Yeah, weird. Okay. Yay, crew. I do apparently have it installed. That's odd. Let's try and install it again. Yes. Crew. Info. What? Oh, that's odd. Let's just do crew -d crew bin. Oh, sorry. Crew -r bin. Yes. And then try that again. Crew. Really? No? Kubectl? Ah, good. Okay, there it is. Sweet. All right. So we got that set up. Now let's go back to the docs. We're going to do the crew installing method. Kubectl crew install trace. Interesting. Kubectl crew install trace. called trace. Kubectl-trace. Sweet. We have our command. We have things installed. That was actually pretty quick. One of the neat things about this, the way kubectl plugins work, I wanted to show you this because I think it's actually pretty cool. So the way the kubectl plugin piece works is that you have anything with kubectl dash and then a name is registered by kubectl as a plugin, right? And so this binary, kubectl crew, is a binary that can be used as a plugin to kubectl, and in all of the contexts that kubectl has can be made available to that binary. There's a tmux one that I use pretty often, and also a trace one that we just installed. And I think let's just look at the kubectl tmux one, because I've been super impressed with that one. So if I do kubectl tmux minus L minus N cube system minus L case app equals Cilium bash. Oops, I spelled it wrong. Then what happens? It's really cool. It'll just pop open a terminal for every one of the matches. Okay? And so in my case, I was doing a label match inside of the namespace, looking for all of the Cilium pods. It will pop open a terminal for all of them, and it'll put it in broadcast mode. Right? So I can do things like Cilium endpoint list and see the output across all of the different across all of my different outputs. And so that is like a super cool feature. I remember Chris Short actually pointed that out when on his feed at some point, and I was like, "What? That is awesome!" So kubectl, and I think it's actually not called tmux; it's called something else, tmux, like Kate's tmux or something. But I shortened it to tmux, and that worked out pretty well for me. So we got our environment. Let's go through some of these examples and see how this works. So we've got our install. The packages are available. Oh, neat. I could have actually just installed it straight from Arc. The architecture, let's take a look at that. Since it is a kubectl plugin, kubectl-trace doesn't require you to install any component directly on your Kubernetes cluster in order to execute your eBPF trace programs. However, when you point it to a cluster, it will schedule a temporary job there called trace runner that executes the program. So this is the idea that I was talking about before, right? Any plugin that you have to kubectl, I mean, and I've seen people have the argument that a plugin to kubectl is also kind of clearly a security problem also, but I think that you can be really clear about what permissions you're giving to those plugins. And it's to some degree, it's like, it's the age-old battle of convenience versus security, because you're in a state where it's very convenient to have a plugin model for kubectl. At the same time, security-wise, you're granting the permission that you have for that user with his authentication or with their authentication to whatever the target Kubernetes cluster is. Directly, effectively, you're just handing that right over to that plugin, and that can be kind of interesting. So, it can be kind of wild. So, let's take a look. So, trace runner. This figure shows the general idea. You create a config map. You create a job. You can get logs. kubectl-trace can do those things. There's an exec plugin. So, on your laptop, you can do these things, and then you're bumping through the API server, of course, running a trace runner pod, and that trace runner pod execs BPF trace against the kernel. So I imagine that there's going to be some intelligence right here that has to understand what node to deploy that trace runner to, so that it can best create a BPF against a kernel that is shared with with whatever your target process is. And so to talk about that a little bit more, right? Say I have a bash process or a Go app or what have you running inside of node 1. And I want to be able to use the BPF trace program, a counter, and I want to be able to count how many times a particular function inside of a Go program is called over time, right? So I want to basically do a BPF trace and inject a counter that watches for a function inside of a process running on code to be run. And every time it gets called, I want to be able to increment the counter and understand that that's happening many times. And eBPF can let us do that, right? Because every time that happens, we can actually have all the context necessary to be able to say this function happened in this process at this time, and I incremented the count. But to do that, I need to be sitting on the kernel where that process resides, so that I can have the context necessary to understand that it's time to increment that counter. And that is where I think the trace runner pod comes in here, right? You can think of it sort of like thinking about it like one of those Kubernetes debug containers that exists now, where you can like attach a container to an already running pod, and that container can have things like debug programs and that sort of stuff. Anything you need to actually troubleshoot what's happening with that process. We're going to do something probably very similar with this trace runner pod. Basically drop it in, give it enough privileges so that it can actually inject eBPF code into the kernel and make sure that it's injecting that code into the correct kernel where your process is running that we're going to watch. That was a lot of words. I hope that made sense. But we're going to work through it and play with it and see how that works. I mean, I guess technically you could do it as a daemon set, and it would just operate on all of the nodes. But we're going to get into the examples and see how this works. It'll be kind of a fun one to watch, fun one to work through here. So in this case, we are running a program that probes a trace point on the node, so we can do a node level. Let's enter count. Oh, cool. Well, let's try this one out. See what happens. Actually kind of curious if this will do anything for us at all, but let's find out. So what I'm going to do is I'm going to change the parameters here. And this is called demo-mo2. Control A, break that just for a second. Kubectl, get nodes. Yeah. One of the interesting things about Minikube is that when you do create multiple node clusters, they only ever create one controller or one control plane node, as far as I can tell. But the subsequent nodes that you've added become workers to that cluster, which is a reasonable place to start. And you don't really, I don't think you could pick the name of those objects. I haven't looked into the code so far to see if that was possible, but that does seem to be the case. So let's go ahead and run our program and see what we see. Get pods -a. So we have our kubectl-trace container creating, and then kubectl-trace completed. I'm going to explore that pod real quick. So let's see, kubectl describe pod. Now we targeted a particular node. Let's see how this is configured here. So we dropped it into the default namespace, probably because we didn't particularly care too much. It did land on demo-mo2. Annotations. Wonder how they attracted it there. Node selectors, none. They probably just populated the node name directly, is my suspicion. Because I don't see any selector. Like, you could actually do that with selectors in the configuration of the pod as well, but it looks like I don't see that being set here, so likely they just did that with by populating node name. Now here's what I'm talking about when I say that, right? If I do kubectl edit pod kubectl-trace. So this is the pod manifest for this particular piece. It's running as a job, and you can see like there's a bunch of owner references and things like that. Maybe we should look at the job to see how they did that there. But oh, look, there it is. That's how they did it. So in the spec, node affinity. So they did it with affinity. Affinity, node affinity required during schedule, ignored during execution, node selector terms, match expressions, Kubernetes IO hostname in demos MO2. So this is actually how they attracted this work, this job, to this particular node. Is they just spec'd out the hostname affinity. So that works out. But another way to do that, that doesn't work in every environment, is to actually populate this field. So most of the time, people think perhaps that this particular field is not something that you can populate, but it is in fact something that you can absolutely populate. You can populate this on a pod, and then even if the scheduler is not running or what have you, you could actually deploy that pod directly. And this is part of one of the reasons why I always say that admission control is so important, because like there's a lot of kind of interesting holes like that. You need to have something that actually protects you from like having people just do whatever they want inside of your cluster. Let's take a look at some of the other stuff that is true about this pod. So it is actually mounted lib modules on the host. It's a host path mount. Is it a host path mount? That's the mount path. Where's the volumes? There we go. Okay, so it is a host path mount. Mounting user source. Ooh, that's interesting. Mounting lib modules. Mounting sys. sysfs. Mounting all of these things directly into our pod. And then also down here below, what I saw was there was another parameter, this one right here, host PID. So this, so clearly, and for good reason, like if you run a trace program, the pod in which that trace program is running has to have like a lot of privileges on that underlying host to be able to do its work. So understandably, like if you're looking at the permissions of that particular pod, you should probably be a little alarmed, right? There's host path in there. We're giving it host PID. I suspect it's running as privileged, but let's take a look at that. Where would that be? Yep, sure enough. It is running as privileged. One of the upsides here is that they are actually providing resource limits and requests, CPU and memory requests. That's actually pretty cool. A lot of projects that I've seen don't actually do that part, so I thought that was pretty neat. The command that they're running is trace runner, and the program that they ran, it's image pull always. I think that's the default now. Ooh, it's running the latest, so hopefully that's pretty stable. And then the command, the pre-stop command is PID of eBPF trace, so it's basically looking for that. Ooh, that's actually kind of interesting. So this, because we're running in host PID, it's going to send an interrupt to any instance of BPF trace. So it makes an assumption that it is the only instance, because we're not running in our own PID namespace. So in this case, it's going to send SIGINT to all of them, not just the one. So that might be kind of a bug. That's kind of an interesting output, because what that means is, like, say maybe I have what I'm trying to get at here is like I have two different processes running on node 1, and I have multiple traces running. So I have a trace project running against process 1 on node 1 and a trace project running against process 2 on node 1. With pre-stop happening here, I think that it's going to send a SIGINT to both of them, even though it may not be specific to one that we're looking at. So it'd be kind of more interesting to see if they could handle that signal handling like directly toward the one process that it started, rather than all of the processes that it could be related to. But that's kind of interesting. Hello. Good to see you, Bajanch. I'm probably totally slurring your name. I'm sorry about that, but good to see you. So that's kind of an interesting thing. When I look at that, I wonder if that's going to mess things up, because I do. Maybe we'll play with that. We'll see. We'll see how we go. It's got a mount path of programs. Got the default service account. It's got a config map. Let's take a look at that config map. Cube-kettle-trace and then a UID. Cube-kettle edit. Got some annotations. namespace. Doesn't really look like a lot of content. Oh, that's it. Enter. So some labels and some annotations, but no real content in here. Oh, this program BT is trace point syscall. So that's actually how they took that string literal that I created on the command line, and they put it into a config map and called it program BT, and that way they could mount that program BT and call it the pod. And so that's how that part works. Let's go back to our docs and see what the next step here is. So if we run it, don't need to set anything up, it's 100% ready. In this case, we are running a program that probes a trace point on the node. I've run the program trace point, but now I want to see the output. And inside of here, I don't yet see how that works. So let's just explore a little bit. Kubectl-trace help logs. Let's do that. I guess we're not really. We just look at the node logs. kubectl-trace logs, and then this thing. So if I do maybe what I need to do is kubectl-trace get. Aha! All right. Kubectl-trace logs. No trace found with the provided criterias. So it doesn't seem like anything came of it, which is reasonable. Oh, interesting. I messed that up. That's kind of a confusing thing. Maybe. So what I was noticing was there's two different logs. You can do logs from a trace using the trace's name, or you can do logs from a trace using its ID. And the output is different. And so if we do Linux types.h, file not found. Ooh, interesting. Now I have seen this before. And I think what happened here. Find types. Yeah, give me 1 minute to think about this. What happened? Oh, but that's on the host. So what it's to do is actually compile that into a BPF code byte that it can inject into the kernel. And what's happening is Cilium is failing to accomplish that because what's happening is that it looks like the library match isn't working. And I had this problem on a machine that I brought up, like a Vagrant host that I brought up as well. So this is probably related to the same thing, wherein like it's mapping in the BPF helper stuff into a different name. Let's see if I can figure that out, but we'll look at that here in a second. So how are you all doing? I think the node name running into the trace. Yeah, I think you're right. Maybe you could drop the node name. I did finally get the output, Rory. Hello, Rory. Good to see you. Why are they concatenated? Yeah, I messed it up. So, I did actually just hit this. Include ASM generic. Yeah, see, that's the thing. These two directories, there's ASM and ASM generic. And I think what's happening is that that's where it's busted. So this went to MO2. So let's just jump in there and take a look at that real quick and just see if we're on the right track or not. So minikube SSH minus CD C demo minikube SSH minus N demo MO2. User include. It's just include. Oh, maybe it's actually. Oh, but it is mounting it in, right? Okay. SELSB. Oh wow, this is really cut down. Which makes sense. No. Linux from scratch. Bum bum bum. All right. Anybody know what the package manager for Linux from scratch is? Probably have to know what it is. Maybe it's emerge. No. So now we're in an interesting situation because I'm not sure how to proceed from here because the VM I'm using doesn't have the pieces that it needs to be able to move forward. So one thing we could do is we could bring up like a couple of just KVM containers and use kubeadm to link them and then do this again. But kind of an interesting problem. All right, let's see here. But let's go through some of the other examples and see if we can find one that we can get working. I suspect, given the output that I see here, that we're going to run into this problem a few more times. But let's give it a try. So here's an example of what we were talking about before, right? So here is an example of kubectl-trace running against an application. We have the container PID, and we're looking for the main function and how many times it's actually run. So this is a pretty decent example of how that works. See if we can do some examples here. No, that's not what I want. Against a pod or a node. In general, if you run kprobes, kret probes, trace points, software, hardware profile events against nodes using the node/node name syntax, or just using the node name, node is the default. When you want to run a probe against a user space program, so like that actual Go binary that we talked about, with a uprobe or uret probe, or use a user level static trace point, USD, your best bet is to run it against the pod itself using the pod name syntax. It's always that running a program against a pod as of now is just a facilitator to find the process ID for the binary you want to probe on the root process namespace. That's actually pretty slick. So what they're talking about here is because we're actually we need to determine what the please. So if I run, you know what? A picture's worth 1,000 words here. So let's do this. kubectl run git nginx image equals nginx. I'm going to run one pod with nginx instead of it. Cool. Except I didn't mean to do run it. I meant to just do run. kubectl get pods. Cool, it's running. kubectl get pods dash o wide. So it's running on MO3, which is fine. And if I jump in here, kubectl exec dash ti nginx bash. I do ps minus ef. Or that's interesting. Update. Actually, let's just do ls proc. So these are the process IDs that I see. 1, 292, 32, 33, 34. And one cat proc 1 command line is our master nginx process, right? And the others are going to be forks of the nginx process that handle calls and stuff like that. Looks like you need to curl the headers and install that way. There's a page for running. Oh, cool. Would you mind, let's see, if you go to the notes, right, it'd be great to see that in the notes. I could actually just follow that. Again, if you go to, let me just put the banner up here, or the brand. You go to the notes, hackmd.io/@echo-live. You'll find episode 12, which is the one we're on, and you can just drop the notes right into the chat, or right into the notes there, and then I can work on them from there. So if you could do that, that would be awesome. I'd really appreciate that. Let me take a look at that. But that would be sweet. Yeah, that would really help. Okay, so like I said, what's happening here is I have PID1 running as nginx, and I promised that on that node, PID1 is not nginx. But if we jump into that node, right, cd demo Cilium, and then we do minikube ssh minus n demo mo3, and we do ps minus ef. The nginx master process is this one here. And it's operating under is right here, right? 4916. And so the convenience method that they're talking about in the docs here is basically a way of determining what actual PID that particular process is running as inside that particular host, right? So if you give it that particular, you give it a pod name, it's going to look and try and figure out like what the actual PID is, so that it can associate the eBPF program that it's going to inject with the correct process that the kernel understands. You can't give it the process ID that's running inside of the PID namespace, because the kernel is going to be like, do you mean PID1 from like the actual Linux kernel's perspective? Because that's going to be like systemd. So interesting call out. That's actually pretty cool. It's always important that running a program against a pod, as of now, is just a facilitator to find the process ID for the binary you want to program. There we go. You do the same thing when running in a node, but by knowing the PID of the process yourself after entering in the node via some other medium like SSH. So running against a pod doesn't mean that your BPF program will be contained inside of that pod, but just that it will pass your program some knowledge of the context of a container. In this case, only the root process ID is supported via the container PID variable. You know what I wonder? I wonder if, so they do actually call out the root process. So if you're using like, so if your container starts up and it's running nginx as PID1, like in our case, then this should work, right? If your container starts up and you have some like lazy is actually handling reaping of orphan and that sort of stuff, then that won't work, right? Because you wouldn't know what the actual PID ID of the program that you want to evaluate is. You want to know the PID ID of whatever the init process is that you're running inside of your container. So that's what that's about. That's kind of interesting. And you can pass a particular service account. If you have pod security policies, yeah, that's a good point. If you're running pod security policies, clearly a lot of those things would be locked control, not just pod security policies. So like if you're running OPA or any of the other things, you're probably also going to want to change that. You can change the namespace default here if you created it into a different namespace. You can change the type of job. There's different patch strategies. This is all just basically leveraging regular kubectl patch stuff. Nothing specific to this particular tooling. All right, so there are example BPF trace programs. These are actually just the BPF trace programs. So whatever the program, these are just examples of things that you might want to care about or that you might want to look at as associated with either a node or a process. There's a lot of examples in here. This is really cool work. Some of these are 2 years old, but it's really awesome. Very, very cool. So these are the examples. So these are examples of things that you can run, like if you wanted to have like the file watch instead of like using like a string literal, like the one example that we did. But yeah, tons of really interesting things. And then they have both the program a URET probe against bash and an example output attaching 2 probes, df-h, ls-l, echo hello BPF trace, echo is the failed command, like stuff like that. Might be kind of fun to try this one out, but I suspect we're going to run into the same problem. So let me jump back into the notes here. And here is a link that my good friend Rory put up, running eBPF programs in eCHO. So we got that. We did that. You'll need to download and extract the necessary kernel headers within Minikube. So let's try this out. Cilium, Minikube, SSH, MO2. They kind of have it scripted, but what you name -a 419.182, 419.94. How do I have a newer kernel header than the one they're talking about? It's kind of funny. So I'm going to grab this stuff, all of it. Headers.sh. Node 419.182. Plus 19.94, 19.182 global. Okay. And node. 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 For node in. Do. Headers. So for node in demo, demo mo2, demo mo3, do the following. Should work. Let's try it out. Chmod plus x headers. Unhappiness. What is it complaining about? Looks like this does not exist. Bum bum bum. I can't ls it either. Okay, so we're looking for these headers. Text. Cube. Interesting. Maybe I messed it up. Let's see. Somebody in the comments telling me I messed it up. Added the notes. That's good. Uname -a 419.182. I suspect maybe they just didn't build headers for this version of the kernel. Yeah, that's kind of what I was thinking too. Well, I think we're gonna get stuck here, and we're gonna come back and do this episode again, but with better prepared, because I thought that's what actually work. See if there's a way for me to grab a header somewhere else. Although I would not recommend doing this generally for my particular purposes. And it looks like no. I just look for a different type of compilation for it, or a different type of packaging for it. Tar. Hey-o. 419.182. 19, 182. What's the change log? Okay. What do you think? Are the headers going to be in the source? Seems like they must be, right? Oh, since I looked for just the headers. Cancel. Copy link address. Kernel minus hello. Ooh, it's actually, we've been in for an hour, so I think I'm going to have to leave soon. I think I'm going to put this on hiatus and come back and work on this more with you in the future once I actually have this worked out. So I do think this is a super interesting program, and I've learned a bit. I've learned quite a lot about the application. I hope it was useful for you. And in 2 weeks, I have a special treat. I've talked to Antonio Ochea, who works with me in the KIND project. He actually put together a really interesting thing. He was actually trying to solve a real problem that he had, which was basically like, you know, how do I prove that the problem that a user has is IP tables? And so he wrote this thing called netcat. Kind of a fun one. And so I'm going to have him on, and we're going to talk about netcat and how it works, what the problem he was trying to solve is, and show how netcat solves it. And he'll be on in 2 weeks right here at the same time. We're going to do that interview, and then probably the session after that one. I think that I'll be taking an early morning session because Liz will be out that week, and so you'll see me announce it on Twitter. But I'll probably be jumping back in and working on this one some more. I feel like we hit some roadblocks pretty early on, but I definitely am looking forward to doing more work on this one, and I'll make sure that I have figured out beforehand. So if you're interested in understanding more about netcat, you can find that project here, and I'll link it into the notes in 2 weeks. AOGL with shift insert. So it'll be fun to dig into that one. You know, like I love digging into like real world problems that people use eBPF to solve and that kind of stuff. I mean, and if you are on a journey with eBPF and you're interested in coming on live and talking about what you've been up to and like how you're learning it and like, you know, what you've discovered in your journey, definitely reach out, hit me up on Twitter. I'm really looking forward to kind of like trying to turn eCHO into a place where we can like talk about real problems that eBPF solves and kind of show like and learn together. So if that's something that's interesting to you, hit me up. I'm at Maui Lion on Twitter and everywhere else. And I hope you all have a great long weekend. So enjoy July 4th, those of you who will celebrate. It's true, yeah. You know, I just like everybody else, I do sometimes get owned by the demo gods. You know, it is what it is. But I think I'm looking forward to the next one. So thanks, everybody. We'll see you all next time.